So in this lesson, we are going to see how we are able to use factoring to find the maximum or minimum values for a quadratic. So maximum or minimum values happens at the vertex for a problem. So before we start to find the maximum minimum by factoring, we want to review of the key characteristics of a quadratic. So the graph of a quadratic relation is called a parabola, and we have several terms you need to know. So one is the graph intersect with y-axis, we call it y-intercept. That is same as a linear relation. So a line intersect with y-axis is y-intercept. Then the graph intersect with x-axis, we call x-intercept. And you will see you always have one y-intercept, but you may have two x-intercept, or you may have one y-x-intercept, or you may have 0 x-intercept. So if the graph is above the x-axis, it doesn't have any x-intercept. If the vertex is on the x-axis, then you have only one point of intersection with x-axis, then you have only one or called two equal x-intercept. Point of intersection with x-axis is x-intercept. Point of intersection with y-axis is y-intercept. And for the parabola, we have two special terms. One is a turning point, we call it vertex. The turning point before this graph is decreasing, then from here is increasing. So the slope is negative, is decreasing, slope is positive, is increasing. From decreasing to increasing, the turning point is vertex. And the line that passes through the vertical line passes through the vertex, we call it axis of symmetry. And also you could write it as A dot O dot S. Now we are going to see one scenario that could be modeled by a quadratic relation. So a bird spots a fish, and the depth from a cliff could be modeled by y equals x minus 1 times x minus 3, or you could expand it to get the standard form. They are equivalent. So we are going to see from this example, we create a table of values, the first differences and second differences, the characteristics of a quadratic relation. So we create a table of values by substitute x value into either the first factored form or the standard form. So x equals 0, we sub in, we are going to have y equals, if you use standard form, is 0 squared minus 4 times 0, then plus 3. Then we do the calculation, you will find out it is equals 3. So it means you have 1.0, 3. Then we do the same thing to the 1. X equals, so 0, 3. This is the first point, and sub in 1. We could sub in this one to the factor form. So 1 minus 1 give you 0, 0 times anything give you 0. And sub in 2, 2 minus 1 times 2 minus 3 give you 1 times negative 1 is negative 1. 3 sub in 3 minus 3, 0, 0 times anything give you 0. 4 minus 1 times 4 minus 3 give you 3 times 1 is 3. So we have this 1, 2, 3, 4, 5 points. Then we could graph it. 1 is y is 0, 2 y is -1, 3 y is 0, x equals 4, y equals 3. So if we connect it, you will see it is a problem. It's a U shape. Then we are going to see if just given a table values, how you can tell it is a linear or quadratic relation. So we are going to find the first difference. First difference is also you could think is rise. And the difference of x is your run. So from 0 to 1 is right 1, right 1, right 1, right 1. Then we are going to see the rise from 3 to 0. The difference means subtraction. So equals -3 is down 3. From here to here is down 3, right 1. The slope is -3. And from 0 to -1 is down -1. So from 0 to -1 is down 1, right 1. So the slope is -1. And from -1 to 0 is right 1, up 1. And from 0 to 3 is right 1, up 3. Then from here you will see the slopes are not same. So it is not a straight line. And after that, we are going to see the second differences. Second differences means subtraction of the first differences. Subtract. Difference means subtract. So -3 to -1 is -1 take away -3. You will have -1 plus 3 give you 2. Then -1 to +1 is up 2. And the +1 to +3 give you +2. So from here you will see that the second differences are same, and that is an important property for a quadratic function. So if the second difference is same, then this table values, this set of data is a quadratic function. Okay, so from a graph is U shape. It's U shape, then this is a quadratic. Okay, quadratic is U shape. So that is one example for quadratic function. So now we are going to see determine the vertex by factoring. So from this graph, state the zeros of each of the following graph. So this is 1, this is 4. And from the factor form, the zeros will be x minus 1 equals 0, give you 1. And the x minus 4, 0, give you 4. So 1, 0, 4, 0. And the algebraic way to find it is x minus 1 equals 0, solve it, we have x equals 1. X minus 4 equals 0. Then we move the 4 to other side, you have x equals 4. So you have these two layers. This one you could see from the factor form right away, okay? And for the y-intercept, how to find y-intercept is on the y-axis, x equals 0. Then we sub in, you are going to have y equals 0 minus 1 times 0 minus 4. Then you will have positive 4. And now we are going to see from algebraic method, how to find the axis of symmetry. The axis of symmetry is at middle of these two x-intercepts, so it will be midpoint of 1 and 4. So it's 1 plus 4 divided by 2 give you 2.5. And this is x value. We want to find the vertex. On the vertex, the x coordinate will be same as the axis of symmetry. So this is the x value for the vertex. Then we want to find the y value for the vertex. It's just sub the x value into the given equation. Y equals 2.5 minus 1 times 2.5 minus 4. You do the calculation, you will find out it is negative 2.25. So from this question, you will see from the factored form, we are able to find the x-intercept. From x-intercept, we are able to find the axis of symmetry. From axis of symmetry, we are able to find the y coordinate of vertex. Then combine these two axes of symmetry, x value and y coordinate, you found that is the xy coordinate for a vertex. And on the graph, it is 2.5 and negative 2.25. So this one is a graph of this function. So the middle of that two zeros add together give you x equals 2.5. And we sub it back, and this one is 0,4. And this one, we are going to use a graph to check, but from this factor form, we are able to find the zeros. So the zeros will be same as the x-intercept. So it's just x minus 2 equals 0, solve it. X minus 6 equals 0, solve it. You will have 2 and 6. And they are the zeros. Also we call it x-intercept. And for y-intercept, it's just x equals 0 sub in. Whenever you are looking for y value, we do the substitution. Sub x equals 0 and solve for y. So y equals 0 minus 2 times 0 minus 6. It will give you positive 12. And the axis of symmetry is just a middle of these two x-intercepts. It will give you 8 divided by 2, x equals 4. And for the vertex is sub the x-coordinate of vertex is same as the axis of symmetries, x value. So sub x equals 4, then we find the y-coordinate of the vertex. So 4 minus 2 times 4 minus 6, you will have 2 times negative 2 give you negative 4. So the vertex is 4, negative 4. And check this graph. So 4, negative 4 is vertex, 2, 6 are the zeros, and here will be 0, 12 is your y-intercept. So this one is a factor form given, then you could find the x-intercept, y-intercept, and from x-intercepts, you can find the axis of symmetry is midpoint of the x-intercept. Then, from axis of symmetry, we could find the vertex by substitute the x value at the axis of symmetry, and find the y value. So this is the idea that we are going to use to find the vertex. And from the vertex, we are able to tell maximum or minimum. If open up at vertex, you have a minimum value compared to the graph. If it's open down, then you are going to have a maximum at vertex comparing to other points on the graph. So this is what we are going to do to find the vertex from by factoring. So we are going to see. So this is standard form, this is a factor form. So we are going to, from standard form, factor it, and by factor it, we are able to find the x-intercepts right away. So this factor form, also we call it x-intercept form and length-width form. And this one, we call it y-intercept form because c value is your y-intercept. With sub in 0, you have c left. And also this is called standard form. So we are going to consider the method we used here from factor form, find zeros, find axis of symmetry, find vertex to do this, solve this question. Okay, consider the equation y equals x squared plus 4x plus 3. Then fill in this the following information and graph using 5 points. So what's the y-intercept? This is standard form, so 3 is your y-intercept, subbing x equals 0. The factor form will be factor 8, x simple trinomial, find the two numbers, times together 3, add together 4. 3 is a prime number, you don't have other choice, 1 times 3. So add together 4, so larger number need to be positive. Then times together 3, both need to be positive. So we just put plus 1 plus 3, the two numbers we found. Times together equals 3, add together equals 4 in the bracket. Then this is factor form. The x-intercept will be solve each factor equals 0. So x plus 1 equals 0. Solve for x, move the 1 to other side will be opposite. Negative 1, 0, another one, negative 3, 0. And from these two x values, so it's negative 1, negative 3. Then we want to find the midpoint of 1 and 3. Then you will see it will be add these two numbers together, divide by 2. So x equals negative 1 plus negative 3 divided by 2. Then you will have negative 4 over 2, it is negative 2. This is the axis of symmetry, x equals negative 2. Then we need to find the y value for the vertex. So x equals negative 2. The y value of the vertex, when we solve for y, we do the substitution. So negative 2 plus 1, we could use a factored form. Negative 2 plus 3. Then you will have negative 1 times positive 1. You have negative 1. So the vertex is negative 2, negative 1. So we are going to draw the vertex, negative 2, negative 1 here. The y-intercept is 1, 2, 3, it is 3. We have 4 points. We want to find the 5th point. We use a symmetric point of the y-intercept. So this is right 2, then we go left 2. You will have this symmetric point here. So this point you will see is it's a right one, because now I am using the, okay. So this point is -4. So I will relabel it. So this is -3 and this is -4. So this point is x coordinate is just double of the y, the x coordinate of the vertex. So this one right 2, then left 2. So it's just double of this -2. So it's -4 and 3. We have these 5 points, then we could graph. Connect those points. This one, connect them. This one go up. So this is a graph of a parabola using 5 points. So you have the vertex, you have the 2 zeros, you have the y-intercept, and the symmetric point of y-intercept. So 5 points. So you have first point, second and third point, then fifth point, the fourth point, and fifth point is a symmetric point. Of y-intercept. And that point is the y value is same as y-intercept is 3, and the x value is double of vertex x coordinate. Of vertex. The reason is vertex is from 0 to -2, then you need to continue another -2 to make sure right 2, left 2 of the vertex. So it's -4. So this is 5 points to graph this quadratic. The reason why we want to use these 5 points to graph the vertex, because they are the 5 key points. And most of the question may just ask you for the x-intercept, y-intercept, or vertex. So by graphing it, then you will understand better that in future which point are you looking for. Then you solve it. For zeros, you could factor in, or you could use quadratic formula. And for the vertex, you could use 2 zeros find it, or you could partial factoring find it, or you could completing the square to find it. Y-intercept, just substitute x equals 0 to find it. Okay. So this example show you how to use 5 key points to graph this quadratic function. And also you could use if you have the vertex form, you could use a vertex and step pattern to graph it. So this is just one method to graph it. The next one, we are going to practice on using those zeros and the y-intercept, the 5 key points to graph a quadratic function. So the y-intercept standard form is a c value. And what are the factors? Factor it, find the 2, numbers times together -8, add together 2. So you have 2 and 4. Larger number need to have the same sign as a sum. Is plus, another one times together negative will be negative. So -2 plus 4. Then double check. 2 times 4, -8. -2 times 4, -8. The cross minus 2x plus 4x is 2x. X times x, x squared. So it's right. And the x-intercept will be opposite with these two numbers. So it is x minus 2 equals 0, solve. Then you have x equals positive 2. And another 0, x plus 4 equals 0. Solve it. Move to other side is opposite, -4. So you have 2, 0 and -4, 0. The vertex will be middle of these two. So this is just one way to find the vertex. Using the 2 zeros, find it. You will have x equals -1. Then sub it back. You could sub it back to the factor form. So -1 minus 2, -1 plus 4. We have -3 times +3 because vertex is at middle of these two zeros, so it should be same number but opposite sign. So it's -9. So we have -1, -9. And the symmetric point for the y-intercept of y-intercept will be the double of the y-intercept. X value will be double of the vertex. So it will be double of that one is -2, and y value should be same as the vertex. So it will be -8. So now we have the 5 points. We are going to graph it. So vertex -1, -9, we are going to go by 2 for the scales of y-axis. Then x-axis we still go by 1. So the vertex is -1 and -9. Y-intercept is -8. The symmetric point is -2, -8. And the zeros are the 2 and the -4. So this is 2, this one -3, -4. So you have 5 points and just connect them. Okay, so this is how you graph it. Then the next one, find the y-intercept is 0, 4, the last number. And the factors, we are going to find the two numbers times together 4, add together 4. You will see you have 1, 4 doesn't work, and 2, 2. So x plus 2 times x plus 2. Then the zeros will be the factor equals 0, x plus 2 equals 0. So for x, you have -2, 0, -2, 0. We could call them two equal zeros or 1, 0. What is a vertex? So -2, 0, -2, 0, add together divided by 2 give you -2. So So you have negative 2 plus negative 2. The two zeros, they are equal. That means it is your vertex. Then we sub in, it will give you y equals 0. So this time the x-intercept and the y and the vertex, they are same. So the x-intercept will be negative 2 and 0. And for the y-x-intercept, it is 4. And the symmetric point for the y-intercept will be double of the x-coordinate is negative 4 and y value same. So it's negative 4 and 4. This is 0, 4. So you have only 3 points. How you can find the other 2 points? We could sub in negative 1 and find a negative 3 to find other 2 points. So we sub in x equals negative 1, we are going to have negative 1 plus 2 times negative 1 plus 2. So we want to find other 2 points. We want to find the points that next to the vertex. So we take x equals, sub in x equals negative 1, we have 1 plus times 1 give you 1. So this one, negative 1, 1 is here. Then the symmetric point from here, right one, then left one, it will be here. Or you could sub in negative 3 here. So negative 3 plus 2 times negative 3 plus 2, it will give you the negative 3 plus 2, then squared. Because they are same. Then you will have negative 1 squared is 1. So you have this symmetric form. Then connect them. Then you have the graph. So this is using the 5 points to graph it. Then the next one is an example that is no equation given, so you are required to set up the equation. So at the beach, a lifeguard is setting up the swimming area. The lifeguard has 400 meters of rope available to create a rectangular swimming area. The shoreline will form one side of the rectangle. So what is the maximum area for the possible swimming area? So these 3 sides, they are going to use a rope. So together you have 400 meters. So it asks you for the maximum area. For the possible swimming area, it means you want to find the vertex. And for this question, we want to use a factoring method to find the vertex. And the equation not given, so we need to introduce variable. This is a rectangle, and in order to find the area, we need to find the length and width. So we are going to introduce the variable x for these 2 sides, and equals we could say this is a width. So let x represent the width. And we need to figure out what is the length for this rectangle swimming area. So the length will be, you have altogether 400 meter of rope. So one side is x, another side is x. This length will be 400, take away 2x. Then it asks you to look for the maximum area. We are going to introduce a variable y equals area. So whenever you are finding maximum or minimum, we want to let y equals a word after the maximum or minimum, because if we have the graph, you will see this is x, this is y, and if we have a quadratic function, then the maximum minimum value is referred to the y value. So that's the reason we introduce a y equals to the whatever you are looking for, maximum or minimum. So this is two variables introduced, then we are going to write the y in terms of x. So y is area equals length times width, so it's just 400 minus 2x, then times x. This is two factors, so this is a factor form. Then we want to find the zeros. You could use other method, but in this lesson we are going to practice on finding maximum, minimum values by factoring. So this one is factors. The zeros will be y equals 0. Then we have 0 equals 400 minus 2x. Then times x. Two factors equal 0, each factor equals 0, so 400 minus 2x could be 0. Then 0 times x give you 0, or another factor x equals 0. X times x is 0, 0 times anything give you 0. So we solve for this 400 minus 2x, solve for x, we move the x to one side, and the numbers keep it to other side. Then we want to solve for x, move the 2 to other side by doing opposite operation, that is division. We have x equals 200. So the two zeros is 200 and 0. So it means this one is start from the 0. So this is 0, another one is 200. So the midpoint of these two zeros will be the x value for your vertex. So vertex, the x coordinate is half of the two zeros, middle of the two zeros. So x equals, it is 100. Then we sub in to solve for y. So y equals 400, take away 2 times 100, then times 100. You will have 200 times 100, it is 20,000. So this is a y value 20,000. Then you will see the vertex is 200, 20,000. Then this one, if we expand, you will have 400x, take away 2x squared. So we know that if a value is negative, then it's open down. So at this vertex, you will have a maximum value for the area. So this is the maximum value area is 20,000 square meters. And if you want to find the dimension, then you will see the width is 100 and the length is 400 minus 200. 2 times 100 is 200. So this is the length. This is width. So if you are looking for dimension, then it will be the dimensions are 200 meters by 100 meters. Thank you. So this is for that question. It didn't ask you for dimension, so you could just say, okay, the maximum area is 20,000 meters squared. So this is for factored, finding the maximum minimum by fully factoring. And also you could have another method if it's the quadratic function is not factorable. How are you going to find the vertex? By factoring. So we could determine the axis of symmetry of each parabola. Each pair of points are the same distance from the vertex of their parabola. So it means they are symmetric points. So you have 2 points, -2, 3, 2, 3. So it means you have 2 points, -2, 3, 2, 3. So where is the axis of symmetry? The middle of that 2. It will give you x equals just -2 plus 2 divided by 2. That is the midpoint of these 2. That is the axis of symmetry. X equals 0. And for the question B, it's -6, -2, 3, -2. So you have the two y values same, and they are symmetric points. So it's -6. Sorry, it's -6, -2, and this one is 3, -2. So you will see if they are symmetric points, then the midpoint of these two will give you the axis of symmetry. So, and the midpoint is -6 plus 3 divided by 2. Then you will have x equals -3/2. So this is axis of symmetry. And this one, axis symmetry, it will be the 2x coordinate add together divided by 2. So do the calculation, you need to have the same denominator for the numerator. So the least common denominator for these 2 and 4 is 4. So we are going to times the first one by 2 to both numerator and denominator. So you will have -2 plus 3/4 divided by 2. So equals 1/4. Then divide by 2. We could change it to 2/1, so times, flip it, 1/2. Then numerator times numerator, denominator times denominator, you will have 1/8. So this is from the symmetric point. You could, on the problem, you could find the midpoint, then you have the axis of symmetry. And the method that we are going to show below is using this method by partial factoring. If a quadratic equation is not factorable, then we are able to find the using partial factoring to find the maximum minimum value. So this one not factorable, but how we are able to find the axis of symmetry, we are going to find the symmetric points of the y-intercept. From this one standard form, we know we have y-intercept a negative 35. So we want to find the symmetric point of the y-intercept. So it's negative 35. Then we want to find the x value. Once we have the x value, then we know the vortex is at the middle of these two. So we want to, this one is 0, negative 35. And another one will be double of the vortex x coordinate, negative 35. So we want to find this point. We are going to let y equals negative 35. By doing this, you will have negative 35 equals 4x squared minus 4x minus 35. Then we move everything to one side in order to solve this quadratic equation. So negative 35 move to other side becomes plus 35. It will cancel out with minus 35. So you have 0 equals 4x squared minus 4x. So once we get rid of the c value, you will see you have a quadratic function could be factored all the time because you have the variable x as a common factor. So for this question, we also have 4. So 4x, then bracket, each term divided by 4x is common factoring. You will have x minus 1. Then we find the zeros. So we divided 4 to both sides. The 4 is gone. You will have x minus 1 left as factors. Each factor could be 0. Then you are able to solve for x. This one is positive 1. Then the middle of these two, so this is 1, negative 35. The middle of these two will be, add these two together, divided by 2. Then you have x equals 0.5. Then in order to find the y value, we just sub in the x is equals 0.5 to the original equation. So 4 times 1 over 2 or 0.5. So I will use fractions. Minus 4 times 1 over 2, then minus 35. Use your calculator to find out. So this one is 1, this is 2, minus 35. You will have negative 36. Then, because it's open up, this is 4 positive, so you have negative 36. Then open up. So you have a minimum value. So we are going to write statement. Therefore, the minimum value is negative 36. So when we are talking about maximum minimum, is we're talking about the y value. Okay, the y value is the highest or lowest point on the graph. The vertex is highest or lowest point. The vertex is lowest point, then the y value is a minimum for the whole graph. Thank you. So in this lesson, we have discussed two methods to find the maximum minimum value. So one is fully factoring, then find the fully factor it and find the zeros. Then we find the midpoint, x coordinate, that is a x coordinate of vertex, and sub the x value back to find the y value. That y value is your maximum or minimum value. And if a quadratic function is not factorable, then we do partial factoring. We find the symmetric point of the y-intercept by letting y equals the c value, the negative 35, then cancel them out. You will have an equation that always factorable. You are going to have x as a common factor. Then you find the zeros, find the midpoint, then sub back, find the y value, that is your vertex y coordinate. If open up, you have a minimum. If open down, at vertex, you have a maximum. Thank you for watching.